Hey everyone, and welcome. Today we're going to talk about a chemical that's kind of got the secret double life. It's called hydrogen chloride. You probably know it by its other, more famous name, but we're here to get the full story.
And get this, the star of our show, it's actually inside you, right now. You know that powerful acid in your stomach that's digesting your food? Yep, that's hydrochloric acid. And what is that? It's just hydrogen chloride gas dissolved in water, the exact same stuff we're going to break down today. Okay, so before we see what this stuff can do, let's get its basic profile down. Think of this next part as its official ID card, for hydrogen chloride, or HCl for short. So here are the key facts. The formula's super simple. HCl, one hydrogen, one chlorine. Now what's really important here is the bond type. It's covalent. That means the atoms are sharing electrons. And that little detail is going to be a huge clue to how it behaves as a gas. And like we said, you find it in some pretty wild places, from volcanoes all the way to your own gut. So where does HCl come from? How do we make it? Well, let's head into the lab and check out its origin story, how we cook up hydrogen chloride gas from scratch. And you know what? The recipe is surprisingly simple. You really only need two main ingredients: sodium chloride, which is literally just table salt, and some concentrated sulfuric acid. Making it is like a precise 5-step process. First, you mix the salt and the acid in a flask. Then you heat it up, but gently. And believe me, that temperature control is super important. We'll get to why in just a sec. The gas that comes out then has to be purified by drying it, and finally, you collect it. That equation at the bottom just shows you what's happening chemically. The ingredients basically swap partners, and we end up with sodium bisulfate and the HCl gas that we wanted. Okay, so let's double back to that heating step. I mentioned it was important. There's a really strict temperature limit. You have to stay below 200 degrees Celsius. So why? What's the big deal? Well, there are 3 really good practical reasons for this. First off, you could crack the glass flask if it gets too hot. Nobody wants that. Second, it just saves fuel, which is always good. But the main reason is this. If you go above 200 degrees, you get this hard, crusty layer of sodium sulfate forming inside the flask, and it is a pain to get out. So yeah, staying below 200 is just smart chemistry.
All right, so we've made our gas, and we didn't break our flask. Awesome. Now what? How do we, catch it? The way we collect it is just as important as how we made it. And this is cool because the collection method actually tells us a lot about HCl gas. First, we collect it using something called upward displacement of air. Basically, you let the gas fill the jar from the bottom up, pushing the air out the top. We do this because HCl gas is about 1.28 times heavier than air, so it just sinks. And second, notice we are not collecting it over water. Why not? Because it's crazy soluble in water. It would just dissolve instantly and poof, gone.
Okay, now this is where HCl's personality gets really interesting. It's like it has a split personality. As a dry gas, it's one thing, but the moment you dissolve it in water, it turns into something completely different.
See, as a dry gas, it's a covalent molecule. It's pretty chill. It doesn't conduct electricity. It won't change the color of litmus paper. But then, you add water, and everything changes. It ionizes. That means it splits apart into hydrogen ions, the H+, and chloride ions. And those free-floating hydrogen ions, that's what makes it an acid. Suddenly, it can conduct electricity, and it'll turn blue litmus paper red, the classic calling card of an acid.
So, just how soluble is it? How much does HCl love water? Well, there's this fantastic experiment that shows it off in a really dramatic way. It's called the fountain experiment. Okay, check this out. In the fountain experiment, you take a flask that's full of dry HCl gas, and you introduce just a tiny drop of water. The gas dissolves into that water so fast that it creates a huge pressure drop inside the flask, basically a vacuum. So what happens? The higher air pressure outside forces a jet of blue litmus solution from a beaker below to shoot up into the flask, creating this awesome red fountain. It turns red because the solution is now acidic. This one experiment shows us 2 massive things. 1, that HCl is incredibly soluble, and 2, that its solution is a strong acid. So now that we've got a handle on its personality, let's look at how this powerful acid actually reacts with other stuff. How does it make its mark? Well, if you drop an active metal, think sodium, magnesium, or zinc, into hydrochloric acid, you get a really classic fizzy reaction. The acid goes to work, dissolving the metal,
and it forms a salt, specifically a metal chloride. And all that fizzing and bubbling, that's pure hydrogen gas being released. Okay, but what about when an acid meets its total opposite, a base? Well, you get what's called a neutralization reaction. When hydrochloric acid reacts with a base, like copper oxide or zinc hydroxide, they basically just cancel each other out. And what are you left with? Always the same two things, a salt and good old H2O, water. All right, so let's say you've got a mystery gas. How can you be totally sure it's HCl? And then let's talk about where this stuff is actually used out there in the real world. There are two dead giveaways, two classic tests for HCl. First, if you bring a glass rod dipped in ammonia solution near it, you'll see these dense white fumes. That's ammonium chloride forming. The second test is to add some silver nitrate solution. If HCl is there, you'll get this thick, white, kind of curdy precipitate of silver chloride. You see those two things, you've got HCl, no doubt.
So where is all this powerful chemistry put to use? Well, in industry, it's huge. It's used for cleaning steel, a process they call pickling, and for making all sorts of things like dyes, drugs, even glucose. In any chemistry lab, it's a staple. And of course, as we talked about right at the beginning, it's absolutely vital inside our own bodies for digesting food and zapping germs.
Okay, now it's your turn. Time for a quick knowledge check. Go ahead and pause right here and see if you can tackle these two questions. It's the best way to make sure you've got the main ideas down. And there you have it. That's the whole story of hydrogen chloride. We've seen how it's made in the lab, and we've explored its fascinating split personality as a mild-mannered gas and a super powerful acid. It's a compound that's just as important in a giant factory as it is inside your own stomach. Hey, if you found this explainer helpful, do me a favor and hit that like button, share it with a friend, and subscribe. Oh, and don't forget to ring that bell icon so you don't miss the next one.